Hello, friends. Welcome to my YouTube channel, End-to-End Business Intelligence Training with Deepak. So, hope you're all doing great and staying safe. This is my second session as part of this YouTube channel. I'm going to cover the first chapter as I mentioned in my first session of this YouTube channel, which is the RDBMS, Relational Database Management System. So, it's the most basic part of any database project or a data warehouse project or a BI project. So you have to be very much confident about the basics of relational database management system. How do you design the database through ER modeling and how do you do the dimensional modeling basically. So this session, I would just make it more in a preview perspective in this YouTube channel, but the end-to-end training will be very comprehensive, deep dive, and very useful for any beginner, and also very useful for school and college students as well to understand the database management systems and database projects, data warehousing. So the end-to-end training, I will be sharing at least three parts to cover that. So it can be more than three parts as well. So it will have real-time scenarios, project scenarios. I'll be also explaining with uh, in a failure mode. So when something fails, how do you tackle that troubleshooting perspective and what project scenarios I faced in my own project experience, in my whole 14 plus years of experience in different companies and projects and all the data warehouse BA projects. Okay, so let's go ahead, not taking much time here. So let me share my screen and show you the agenda and the plan. Let me share my screen. Yes, so this is end-to-end DBMS and RDBMS end-to-end training as I mentioned, with real-time scenarios and so real-time scenarios, I mean the project scenarios as well. But this session, particularly in this YouTube channel, will be a preview perspective. Uh, so you can learn about me more in this YouTube channel, what the experience and what are the tips and tricks also I'll be sharing now and then. All right. So please subscribe to this YouTube channel and also click the bell icon for continuous updates on my channel. All right. So going to the next slide. So I have some notions while I teach. So I don't say it is training, but I say always it is teaching. I'll explain you in the next slide on that. Theory is futile without interlink to practical implementation. Obviously, this is very pretty straightforward, but what I would say is when you have an idea, so without implementation, it's futile. I mean, there's no use. Is it's my notion. So knowledge is divine and purifies the soul, and that's my personal experience. So initially, I was not very much, interactive in sharing my knowledge and I mean, obviously, you are learning many technologies. You will have that hindrances in shifting to technologies, and you seem not to share the knowledge. But I would say it really purifies the soul, whatever the knowledge you gain. Yeah. And so too much information is chaos. So I stick to the point, and I stick to the challenges that are faced in a very much practical scenario and a project scenario. Uh, so what troubleshooting you have to do when there is when there is a challenge that is coming up in the project, what kind of errors you face and what kind of troubleshooting you do. Yeah. So I teach by failing things. So without so I do believe in the notion that you need to learn from the mistakes rather than learning from the successes. So you need to learn mistakes done by others. So I teach by failing things, and I feel the new education system also should be based on failures, but not based on success. All right, that's my notion. An empty pot always makes noise. Yeah, I do agree that, and we have to make the noise when we achieve and succeed. All right, so and when you are trained, you're confident. obviously. So training, I would say it is teaching. Training is nothing but learning, but teaching is something you learn by failing things, by failing, in fact. So, i- so if you just you cannot be confident is just go through the interview questions and only reading or studying. So you need to implement that, you need to fail, and you need to do a troubleshooting as well. Okay. So do not think of a failure in interviews. Basically, the interviewer may also fail due to lack of knowledge in other areas as well. So whatever you have, whatever you possess in knowledge perspective may not, the interviewer may not be equipped in that, and his thought perspective may also be different. The approach may be different. So never end up with one interview or something like that. Um, Way of teaching. So for this RDBMS course or end-to-end BI teaching, right? So I'll explain alongside the product, Microsoft SQL Server. As usual, is very pretty straightforward. There's nothing much in it, and it's comprehensive and practical, very deep dive. This course explains all the basics, layman terms as well. Very useful even to the college and the school students to excel in database projects, database management system, BI projects, end to end through practical scenarios. Um, I would say, as I mentioned, so as already told, right? So this is teaching rather than training. So teaching is something you learn by failures, all right? Uh, so you get trained. There are many references online. You can go, you can learn the concepts. The concepts are already in there and referred by many other people. As many other trainers, many trainers, like humongous number of trainers are available, teaching the same concept again and again, and you're getting the same repetitive concepts. The same information is spread across multiple references. So I would not teach the same concepts again and again. They are already there, online reference, but I would teach only in terms of how you would implement in the project, how would you face the failures in the project, and how would you tackle that, and how it will be useful to in your job search as well. How it will improve your confidence, in fact. So it improves your confidence as well in attending the interviews. So very deep dive, and the internals also will be explained how the SQL server executes. So also very diagrammatic and I will explain through some flow charts as well. Yeah. As I explained here, right, diagrammatic representations. So I have an input device called Wacom Designer. So used usually for architecture, but I also use it for diagrammatic representations here while explaining it. So very practical and very intuitive. It's not like the same concepts will be repeated. So there's only once that the concept will be explained, but the practical scenarios will be. I can explain three or four scenarios for each concept. So it's like that. Um, so I tried to integrate the actual end-to-end training to Razor Pay. Will ensure. So I want to ensure that some amount also goes to charity, and I also want to strive in a longer term that no one dies because of hunger. All right. So that's my final goal. But yeah, let me try whatever I can. Previews will be available on YouTube as I explained. So let's go to the concepts and deep dive. So this is only the agenda at the moment. So for this YouTube channel, as I told, it's a preview. Uh, Database, obviously, RDBMS starts with database and database management systems, definitions and implementation. As I told, every concept will have implementation. Okay, structured and unstructured DBMS. But do we need to understand the difference? It's just to understand, but in implementation perspective, it's not very useful at all. So you always deal with the structured DBMS. Uh, okay, so unstructured is something you don't get, like you find it out in applications and all those and PDFs. Yeah. Why DBMS and RDBMS understanding is needed for large scale database, BI process, and we're learning basics. So we are just learning the concept. So why there if we have to learn? Where are you going to use that? In which practical implementation? Which project scenario? That is the most important. It's reading and studying mugging up the concepts. It's very straightforward, and uh, obviously the interviewers will ask the questions, but you feel confident only when you have the practical approach and how you implement that. Why we need them and basis for evolution of file storage to database to DBMS to RDBM. So why, as I already explained in the third point, but why we need them while during the course of evolution that happened from file systems, right? Initially it was file system storage, but not the database. So how it the evolution actually occurred from files to database to DBMS to finally RDBMS systems, RDBMS applications. So a brief history will be there in the successive slides. Definition of database. I would say what is a database essentially? It's an organized collection of data. So it's a simple definition. It doesn't actually help you in a practical scenario, but you just try to understand what is it, the concept, that's it. Uh, and accessed electronically from a computer system through other applications where the DBMS comes into play. So where databases are more complex, they are often developed using formal design and modeling techniques. As I told, right, ER modeling and all those, you integrate many entities, interlink them and all those. So DBMS is the software that interacts with end users, applications, and database itself to capture and analyze the data. Um, Also, it will have the facilities to administer the databases. So you can take the backup of the databases on a schedule, or you can check the statistics of a database, usage statistics, index statistics. Uh, what are the locking mechanisms, lockings that are happening over the database while querying the database. There are many other mechanisms as part of the administration, health of the database, many tools available as part of the DBA database. So I'd also want to explain you that this course also will cover the database administration as well, the end-to-end training. So the sum total of the database, DBMS, and the applications can be referred to as database system. Uh, Sometimes database is DBMS, but I would clearly demarcate both of them. They're not the same. So, but you hear terms there. So in practical scenarios, people use it. So that's why uh, so you need to demarcate that. So database components are interlinked entities. So I'll explain every point in end-to-end training, very deep dive, how they are interlinked, how interlink will happen through ER diagrams, and how what is the cardinality between the entities and all this. So in the successive slides, it is there. I'll explain even in the end-to-end training with real practical scenarios. Very useful in terms of, it's just not learning the concept. If you just learn the concept, there is no use. As I told, ideas, having only idea is not the only requirement, and it's futile if you have only ideas. You should implement them, how well they are applied in the projects. Then, while in fact, when you're recruited into some company through an interview, you would be able to tackle very much good challenges, obviously. So, process for manipulating data in the entities. So, how would you use the DDL, DML languages, right? Data definition, data manipulation, data control languages to update the data. So, it's part of the DBMS, in fact. So, the corresponding data for the entities were previously stored in files, as I already mentioned. So, everything practically, we will explain that. Database is created to maintain asset properties. So, as you know, this is a basic concept in the database asset. So, database is consistent only when you have this property. It's called as a database. All right. Atomicity, consistency, isolation, durability. That is called asset. All right. So deep dive training, as I mentioned, in deep dive explanation of these concepts will be in a different end-to-end training. It will be most in more diagrammatic, pictorial representation and practical representation. So don't miss that end-to-end training as well. I'll be sharing very soon, but at least you will get a preview of what I'm going to deliver in that end-to-end training in this session of this specific YouTube channel. So you can just refer. So this Mostly I'd be sharing this agenda, but end to end, all the concepts, the diagrammatic representation, scripts, everything, flow charts, whatever the transactions that I'm going to will be in the end to end training, and I'll be integrating it to raise our pay. All right. So asset properties are maintained in database to enable that the information retrieval manipulation go hand in hand without affecting the desired result. So even after you update the database is consistent enough. It doesn't have any dirty reads, phantom reads, repeatable reads, non-repeatable reads, and all those. So isolation levels and locking mechanism go hand in hand to implement this asset, in fact. So no duplicity in data, integrity of data remains, no transaction is incomplete, and in case of multiple transactions, it can be accessed and shared with no anomalies. So that's what it is. Usually the bank transaction, right? When the amount is deducted, the other person also sees. Um, other transaction sees that it is deducted. Yeah. How database looks like is pretty straightforward and it's self-explanatory. So represent the database as a cylindrical one. So you have entities and processes there, and the entity looks like with columns and rows. Obviously, this I think hopefully this should be known by everyone by this time. And it is a very common concept when you search for database concepts anywhere you get this. So I just don't want to repeat the same thing again and again, delivered by other trainers and all those very basic concepts. So this employee and the department entities are interlinked obviously through the department ID. So that's a foreign key. So let's go to database versus database management systems. So typically used interchangeably, as I said, but a database is a logically modeled cluster of information that is typically stored on a computer or other type of hardware that is easily accessible. All right. So obviously, as I just showed the database, right? So I would explain this along with the SQL Server Management Studio in parallel. So let me just open the Management Studio here. If I can open that. So you see, this is a SQL server, and I've installed a database here. I created a database. So I'll explain in the end-to-end training how to create this database and all those. So there are many other systems as well: security, server objects, replication, always on management, integration services, which is SSIS, agent jobs. So it's a basic view of the RDBMS database system. All right. So this RDBMS SQL Server, Microsoft SQL Server, one of the RDBMS systems. All right. So let's go to our original one from current slide. Yeah. So database management system is what I showed you. In fact, computer program. There are many other types of data existing in. I mean, the applications are existing in the market. I'll explain in coming slides. So definition. I would explain the definition. Provide an interface for most optimal storage, as I showed you. Database management mechanism. So don't worry that if I can cover this even in the end-to-end training as well again. DBMS is kind of collection of databases using which database can be stored, retrieved, and manipulated. Any application will involve database. For example, you have like the Naukri or the Monster, the job sites, right? So they also store data behind the backend databases. So there's a database that is running in there, and you can also create applications with database in the backend. You can deploy them. You can create your own applications as well, online applications with the database. Yeah. So the main purpose will help us sort of store data, manipulate data, insert, update, delete, alter, access data, share data among different users. These are all common concepts anyway. So database where user access the database, simple schematic. This is all right. Uh, Brief history of DBMS, as I told. So this you can find it out anywhere. All right, but it started in 1970s to 1990s. Edgar Cord basically started with IBM. So you have many other history that is a common history that is available anywhere you search. All right. So 1960s to 1970s, how did it happen? Also, it shows like Charles Bachman had mainly involved in that. I'll be sharing this as well. this slides as well. That will be very, so in terms of agenda, right? What you need to cover as part of this training. DBMS origin causes. So why DBMS has originated? So traditional, essentially the file storage, right? ENIAC times where, so I would actually go to the ENIAC times where vacuum tubes. ENIAC was invented by John von Neumann. So there were some vacuum tubes where the data is stored. Switches, right? Logical switches are in the form of vacuum tubes. So next generation introduced file programs like text Excel. Obviously, you know it, and limitations, books, calculators, files, very huge limitations in terms of data store. You don't have a specific process for specific, I would say, system for processing the input data from the files, and the data is not stored in a specific manner or a specific format that is easily readable or retrievable or reportable. All right, so limitations, as I told, data security, files and books are not secure, data redundancy, duplicate data in multiple files are not optimal to update. So if you are going to update, you have to update in all the, it's not optimal. As there is same data available duplicated across books, anomalies in data are evident. Data isolation, related data is spread across multiple files. Same data is spread across multiple files as well. Programmer data, high impact in the application, depending on files, application behavior and code to be modified. So everywhere you have to modify it. The dependency is huge. Less flexibility of changes. You, if you have to change, you have to change everywhere. So it's less flexible. File system versus DBMS, as I already explained. So pre-application programs were there, C, C++, COBOL, which I mean that actually plays the files, and then they are stored in FAT, VFAT, DAT files. All right. So DBMS comes in between these files and the application. So there's two-way thing running here, right? And pushes the data into the databases. Advantages: data independence, provides an abstract view. Obviously, abstract, right? The in OOPS concepts, object oriented program system. So, abstraction. So, obviously, I'll relate some things to OOPS as well in terms of .NET and C++, C Sharp, all those. Yeah. Hides the details, data representation, and storage. All right. Efficient data access. There's an advantage where we use variety of techniques to store, and because you have the application there, a lot of UI in there, efficient data access can be made easily. Data integrity and security, obviously the security part, as I showed in the RDBMS MS SQL server, data integrity is always ensured. Data administration is easy because there is a UI and there is a one-stop shop application there which maintains all those databases. Database administration is a very huge concept that will also be explained part of end-to-end training. So this end-to-end, the end-to-end training that I'm going to explain is in very layman terms, very practical, as I already mentioned, and it's kind of a unique training. I don't explain, as I told, same concepts again and again. Very, when I say data administration, where I'm going to go into the tool, along the tool, right? I already mentioned along the tool, where I go into the tool, how I do the administration, how I check the statistics, how I check the index fragmentation, how I check, and also use some, uh, how I use, like the commands, like the DBCC commands, all those commands as well. So everything in parallel to the concepts, concurrent access and crash recovery, as I told, ensures concurrent access. Obviously, that's the transactional atomicity, right? Every transaction cannot interfere with another transaction there. Also protects the system from crashes because the RDBMS applications have been designed for robust availability, as you have the high availability in SQL Server 2014. All right. Reduced application development time. Yeah. So important functions that are already inbuilt. All right. They're all inbuilt functions and procedures that are available. So going to the next slide. Uh, structure. See, there is a subtle difference between structure of RDBMS and architecture, as I explained it here, right? The complexities are hidden, in fact. So a lot of algorithms that happen inside the DBMS application. I say relational. So RDBMS, like the SQL Server uses a lot of algorithms. It uses SQL optimizer. The main heart of SQL is SQL optimizer. So how optimizer will connect to SQL CNI, there are other interfaces, network interfaces, ports. How does it interact? So it has its own formula or the engine, SQL engine, right? SQL engine, I say in SQL Server terminology. Yeah. Design is using tables. Tables are derived from entity. As it entity is something like you have a physical object. I can say, a television is an entity, is an object. Sorry. I would say entity, a person is an entity. A human is an entity. A person is an object. All right. So the class and the object, in the terms of OOPS, object-oriented programming concepts. There is a subtle difference, as I told, architecture and structure. So this is uh, it's an inherent, very complicated uh, engine of the DBMS. So I would say the structure is engine. In fact, it has lot many. You see the disk storage, many components, the file manager, buffer manager. I'm going to explain end-to-end training, query evaluation engines, how the flow takes place, all this. So usually this is not required in terms of the practical implementation because you don't actually deal with this, but it's very important to understand as well in terms of how internally the SQL or the DBMS behaves. All right, so let's go to the next. So these are all the explanations for that processor, storage manager, data structures, how different data, query processor components, precompiler, interpreter, all those data structures, how they are. So how the data storage is more important in a practical perspective. So you have static and the transient database. There's transient storage. Static, mostly we put that static data in MDF file. So I'm explaining this in terms of the tool. It's just a preview at this juncture. As I told, I'll show you how it goes in the SQL Server RDBMS, Microsoft SQL Server. So you have MDF files, NDF files. So they're all static storages, and there is LDF file, log file, where transient data, which is ever-changing data, and then it grows into OLTP systems, OLAP systems, and all that's a advanced RDBMS that we dwell into. Yeah. So architecture. So as I told, structure and architecture are different, two different concepts. Physical level stores the record. There is a physical level, logical level data types of the data relationship between the tables. So it's, I would say, conceptual as well, but there is another level, conceptual, which is not actually dealt in this architecture, but that comes under schema modeling there for a database. So I'll explain that in the successive slides. View level expresses on the required attributes. Views, I'll explain this view level as well in terms of the RDBMS SQL Server Microsoft. So as I told you, right? So conceptual schema. So we have the physical database. That's the end product of our schema design. But usually, so you let's start with the external view. So you have few attributes that are exposed to the external users or the business users. That comes from a conceptual schema of all the attributes. Okay. And internal level is storage view. Uh, I would say this is logical level. Internal schema is the logical level. And then after the logical schema is derived, you create the physical database. All right. So DBMS security and access provisions. So users and levels of access can be provided. UI. So who are all the users? Types of user: database administrator, database designer, identifying the data to be so database administrator, all authorizing access, coordinating, monitoring, acquiring software, hardware, tuning the DBMS best performance there, and database designer is for identifying the data to be stored, obviously, right? Choosing appropriate structures to represent and store this data. End users or business users, they just use, they don't have very deep knowledge of the underlying complexities of the database schemas and structure or the architecture. So system analysis requirements, all right, programmers will be the system. So where, so you, so every person can act as a at each level, at each role as well. So it depends on the specific point in time where you are. In fact, DBMS system designers implement mainly. I would say these are the architects. All right, architects, tool developers, design implement tools, operators, and maintenance personnel as well. So transaction is pretty straightforward. Anyone can say that you have a reference anywhere. So it's you have the transaction either completed or rolled back. All right, single unit of logic of work. However, it may comprise multiple operations. Either the work should be done or reverted, like the logical 190, right? Either the switch is closed or in the transaction is completed, or open when the transaction is rolled back. Okay, so you have few things that I will explain in terms of again parallel to the RDBMS application, SQL, Microsoft SQL Server. RDBMS, what is a relational database? RDBMS is relational, right? So why is a relational is all the entities are related to each other. Here modeling comes into play in here. Let's go to the different database models. Hierarchical, I will explain again through schematics in end-to-end training. Relational model, network model, object, but usually these are not much useful in terms of practical implementations. Mostly it's entity, attribute, value model, star schema, snowflake schema, data vault. These all will be in the practical entity relationship model. The mostly used will be entity relationship model, entity attribute value model, star schema, snowflake, data vault. Yeah. Keys. So obviously keys is also a very common concept, but I'll explain very practically. There are different types of keys. Candidate key. So candidate is unique identifier for that, for a table, right? So there's simple candidate, composite candidate, invalid. Simple is like you have one column for the candidate key, like a primary key. Primary key can also be composite key. Yeah. So these are all straightforward concepts. I just don't want to dwell much into this. You can find it anywhere. Entity integration, integrity concept, because it's cannot be null. Primary key cannot be null, but a unique key can be null. All right. It cannot allow nulls. That's fine. It can allow a zero or a blank character. Consideration for candidate keys that are uniquely identify. Obviously, database designer should choose one candidate key with a minimal number of attributes. All right. Give preference to numeric columns. Yeah, that's what. Because the joins will perform much more faster and the indexes also can be applied easier on them. Single attribute, as I told, minimal attributes. Attributes, as you know, these are the columns in the table. Minimal composite, business convenience. All right. Foreign key basis, you know, this simple and straightforward as well. There can be a self-reference foreign key as well. I mean, it's referencing the same table as well. Foreign key, it will, for example, employee will have the department ID and the department entity. The department both are interlinked. Super key. So super key may have unnecessary attributes. So non-key attributes as well. All right. So we have to remove them, in fact, but sometimes you need super keys. I'll explain again in terms of into an foreign key. Anyway, I explained check constraint is a range constraint, like for an attribute or a column, you can give like the value should exist between the minimum value and the maximum value, range of values, right? All about schema. Schema is the logical structure, as I explained you. Physical schema, logic. Physical schema is actually the database. Logical is something like the const. So logical is you have the data types and the interlinks between the entities as well, along with all the attributes. Conceptual is only in the entity level and the relationships. Instance is actually when the actual content of the database at a particular point in time is an instance. Right? So database instance, SQL Server instances also I'll explain through the application. Physical data, the ability to modify them without changing the logical schema. So changes in so very so when you change something in the database, so this concept is also very practical when you're going to change some data in a table that has to be affected in all the areas as a cascading effect. So obviously it doesn't change the logical schema because all the entities are same and the interlinks are same. So that is possible through the Microsoft SQL Server, one of the products, which is the RDBMS application. Phase of database conceptual, as I told you, once you design conceptual, you have the logical, then you have the physical database. Deep dive. So, anyways, all this concept will be covered deep dive. Different tools are available in the market for RDBMS, various applications like banking, education, transportation, income tax, many other. All software companies also their profits, everything will be on this. How integrity is maintained through keys as well. All right. Different tools as SolarWinds, database performance, Oracle, IBM, Multibase, Microsoft, SAP, Teradata, MySQL, FileMaker, Access, Postgre, Amazon, MongoDB. So there are many things. So I'll share this. Anyway, this is a preview PowerPoint or the agenda here. So RDBMS or DBMS terminologies. Row usually, as I told, right, it's called as a tuple or is it called as a tuple or record? All right, and a column is a attribute or field, as I told. So these are all. So as I already told, these are all the common concepts available. So I would not much delve into this, but explain you more practically. So let me just show you a quick view of this inside one of this. So let me go into the tables here into RDBMS. I'm not sure it's taking longer time than usual. Yeah, so system tables, so for example, MSDB, so tables. So just query one. So for example, this is the one. Let me just query table here. So this is a table now or an entity, right? So I'll just do a select top 1000 here. Okay, it's going to take some time. All right. Let me go into this. As a preview, I just don't want to get into another. It may crash out sometimes. Cardinality of a relation, uh, like the number of rows, degree of the number of columns, primary key is, domain range of values. Entity relationship. Oh, is it? Okay. Resume slideshow. As I told, entity relationship modeling. Um, so ER modeling is most integrating task for, as I told, right? You need to create the conceptual schema or the logical schema between different entities, how entities are interlinked. So this recording may end in few minutes, but I would just cover how much possible it is, and I'll cover in the next video. All right. So sorry for the limitation here. I'm not pretty much sure what is the limitation. Application source codes are complex to understand, especially need ER diagrams, right? So even in terms of the business users, as I told in the third point, simple documentation to understanding the functionality of the provided mainly business rules usually the requirement. All right. So there are many tools for this ER diagrams as well. This recording and no. So entity relationship modeling, define entity relationships. Entity are used for database design. So I'll explain you this practically through another, the diagrammatic representations through my input device. All right, I have an input device that is used for architectural diagrams. So I'll explain through that. Uh, Entity relationships, ER approach for ER model or ER diagram, concepts, cardinality to weak entity type, relationship types, uh, ER constructs, notations, what are the notations, how you would do the database schema, translation to relational database again. So that actual entity will be, so I would say it's a logical representation of ER diagram. ER diagram is a logical schema, logical view, in fact, schematic view. It will be converted into physical database, in fact, same thing. And you can also create a ER diagram out of, I would say it's a database diagram out of the database as well. Advantages and disadvantages, we can see it. I hope the recording is in progress. All right. History of ER diagrams, as I told, was proposed by Professor Peter Chen. So you don't need to remember, but it's just for informational purpose. Charles Bachman and James Smart have added some refinements to the basic ERD principles. All right. Usually the first one, Peter Chen. Entity and Edgar Cod as well, mostly. But I don't give much importance to who has done what, but usually in terms of our practical implementations and for the job perspective or for the project implementation, it doesn't actually need it. So entity you can call as already a real world example like employee department or an abstract one. So each record will instantiate the entity. So a person may have a human can have multiple person names, so multiple instantiations of that. So relationship is the natural association entity with another entity. So that is called as ER, entity and relationship. So as I have this schematic diagrams, right? If you see cardinality of it is one-to-one cardinal. So this is implemented through my input device. So this is my own diagram. So the copyright anyway. One-to-one cardinality. So instance of an entity is interlinked to only one instance of another entity. One person can be allocated one travel ticket. All right, no two travel tickets. One too many. So it's the same schematic almost. One person can possess multiple vehicles, right? Yeah, that is one. Many to many. Many employees can have same many to one, right? Can have same manager. Yeah. Multiple employees can write multiple exams. It is a bit okay. Kind of we can get it through the practical implementation as well. So it's the most common issue you face many to many relationships issues, right, between two entities in data warehousing projects when you have two entities are interlinked many. So you'll have to create a bridge table. All right. Just to remember, ER modeling tools in the market, ERWin, SQL DBM. SQL DBM is the most recent tool. I found it very, very useful. You can actually refer it. ERWin is obviously very from a very long time.